Good evening to one and all. My name is Venkatesh, registration number 19MIC0062. Today I am going to explain about the ALP program to arrange a given series in hex bytes in ascending order using bubble sort. Now I am going to explain the command lines used in this program. A mount command mounts the working directory from which DOS box was started, mounts a specific folder from your hard drive. Here command C is used to change the directory from Z to C. Here command CD 8086 used to change the directory from C to 8086 folder. Here .asm means automatic storage management. Now my friend Prashant will continue.
Hello, my name is Prashant. I'm 19MIC0054. I'm going to explain the code explanation. First, labeling the code and data segment as code and data, and supplying the input in the data word. We are supplying input a 4-digit value, therefore we are supplying 16-bit inputs. We are assigning count as 4. Inside the code segment, we are moving the data to AX. The next step, the base we are getting. Then DX we are assigned value count -1. CX for inner loop, DX for outer loop. Our list contains logical address value which can be combined with the base address of data segment and point towards first value 53x. After that, we are moving 16-bit value to AX. Then we compare register to value in memory and we do S1 SI plus 2 for biggest for string 1 value we need 2 bytes. One is lower byte and upper byte. AX content is less than SI plus 2 content. We do not do exchange and we jump to instruction. After that is PR1. While if AX more than we do exchange part, that is stop this value. When PR1 we are incrementing the address and again 1 is inner loop which is connected to CX. And it automatically decreases the DX value by 1. This loop runs until CX is equal to 0 and after that it comes out of the loop and it decrement DX, that is outer loop, by 1 and check the DS is not equal to 0. If so, it direct it to the label. Again finally when DX is 0, the program ends. Then we sort the array. We save the file and exit. Next part will be explained by Venkatesh.
Silent. Here MASM file is an 86 assembler that uses Intel syntax for MS-DOS. Link and debug combines assembled.obj files into executable, and that is debug. Now my friend Srikar will continue.
Good evening to one and all. My name is Rekar Gupta. My registration number is 19MIC0007. Now I am going to explain the first part of the output. Here I am giving the first instruction. T means trace. Here we can see move ds, x. This is initializing the data segment. Now again I am giving the T trace. Here first initializing the 0003 into dx. Now I am again giving the instruction T means trace. Here we can see the dx is initialized to 0003 and this dx is moved to cx. Now giving the trace instruction, we can see this cx will be cx will become 0003 and dx also 0003. Here data segment 0000 is initialized to 0051 and this address of 0000 is sent to SI. Here for checking the data segment, I am giving the instruction D, DS, 0000.
మొత్తం కూల్ వేస్తాను.
Here we can see 51 and then 00,
మధ్యలో
24,
ఖాళీ
then
ఉంచి
00,
జెల్
17
లాగా
and
వేస్తాను.
then 00 and 3 and then 00.
అదే
Because
స్టార్ట్
this can be taken as big endian address. So instruction by so because of this,
అంటే అది మొత్తం క్రీమ్
after
మొత్తం
51
అలాగే
we are
ఉంటుంది
getting
డిజైన్
00 and after 24 we are getting 00 and after 17 we are getting 00 and after 3 we are getting 00. From here onwards, my friend Arun will continue about the second part of the output.
Hi, this is Arun Kiran. My register number is 19MIC0036. I am explaining about the final part of the output. Next time. Here we will first value 51 in SI is stored into the 8th register. Next instruction. And the second value is nothing but 24. We will compare 51 and 24 in the next instruction. If A less than B, we will jump into another loop. Otherwise, we will exchange the operation. The operations we will see in the next instruction. Here, so since 51 is greater than 24, we are exchanging the both values. Now 51 is stored into the 02 register and 24 is stored into the 00 register. Next instruction. And we will exchange again at AX comma address of SA. Next instruction. Here we can show that the value is exchanged. Display DDS000. Initially, the first value is 51, but now it is exchanged to 24, and second value is exchanged to 51. Next instruction. Similarly, other loop also continues. We will go into loop for checking other values. Next instruction. Now we will first we had checked the first and second values. Now we will check the second and third values. Now second value is 51. And then third value is 17. Now we will check for 51 and 17. Next instruction.
ఏం చేస్తున్నావు?
Similarly, just if first value is less than second value, then it will go into another loop. Otherwise, it will exchange the operations. Next instruction. Here we can see that exchanging the both values. Next instruction. So now second and third values are exchanged. In next, third and fourth values are compared, and we will do the operations. Next instruction. Next instruction. We can see that CH value is decreased. So we will do the operations for third and fourth values. Here the fourth value, third value is 51. Next, and the fourth value is 3. We will compare both values. Next. Similarly, if first value is less than second value, then we will go into the another loop. Otherwise, we will exchange the operations. Since 51 is greater than 3, we are exchanging the operation. Here we will see that third value is changed to 3 and fourth value is changed to 51. Next. We had completed our first inner loop. So in first inner loop, we got the value, first value as 24, second value is 17, third value is 3, and final value is 51. Next. Here CH becomes 0, 0, 0. So from this we can conclude that inner loop is completed. Now we will come to outer loop. In outer loop, DH value is decreased by 1. Similarly, we will do the same operations as above. First we will load the DH register into CH register. Now CH value is changed to 2 value. Here we can see that CH is changed to 2. Similarly, now we will load the SI address of 0000. Here address of 000 is 0024. From this we conclude that the first value in the array is 24 now. We will compare the next value with the first value. First value is 24 and second value is 17. We will compare these both values. So if first value is less than second value, we will go into another loop. Otherwise, we exchange the operations. Next. Since 24 is greater than 17, we are exchanging the operation. Next. 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 Now we will see that the values, the first and second values changed. Display. Here we can see that the first value is changed to 17 and second value is 24. And now similarly, we will check second and third values and third and fourth values. Same. Now second value is compared to third value. Similarly, if first value is less than second value, it will go into next loop, otherwise it will exchange the operations. Since it has a lesser value, we are exchanging the operations. Next. Go to next. Okay. So here second value is changed to 3 and third value is 24. Now in coming operations, we will check the 24 and 51 values. Next.
Here
Since second inner loop is completed, we are going to the final loop. Decrease DH. Now DH value is decreased by 1. Similarly, we will load the DH value into CH and perform the operation. So here now we had the first value is 17. In address of 0000, 17 value is there. So we will load the first address in first value into 8th register. Now we will compare the 17 bits and second value. First value is 17, second value is 3. If first value is less than second value, we will go into another loop. Otherwise, we will perform the exchange operations. Since 17 is greater than 3, we are performing exchange operation. Now AH value is stored. Now AH value is stored with 3. Next. We can display that the values. We can see that value changed or not. Here the first value is changed to 3, second value 17, third value 24, and fourth value 51. We can observe that it is in the ascending order format. But still we didn't conclude. We want to perform till CH is equal to 0. Next. Loop continues. Next. Here we can see that CH values become 0. And after decreasing DH also becomes 0. Next. So finally, since GH and DH both values are zeros, we had completed. Just we are move AH comma forcing, and we are making a software interrupt to end the program. So finally, we observe the values whether the values are in sorted or not. First value is 3, second value is 17, third value is 24, fourth value is 51. We can observe that values are sorted. Okay, thank you.